So this is the second section of the Radians chapter for the Year 2 work whilst you're working from home. And I'm going to be talking, it's a small section of work, and this is just to highlight some of the features of graphs when you're working with Radians that you might find useful, particularly when we come on to solving equations. You know all of these things in degrees, or you should do anyway, but it's just showing that it's the same for radians. If you remember that 180 degrees is equal to pi radians, that will help you when we're looking at these conversions. So this first value is just highlighting the fact, and we're looking at green on here, that if I work out sine of theta, so that will be this value here, so this height, that will also be the same as this value here, which is pi, because that would have been 180 minus this theta. So because this gap here is theta, and this gap here will also be theta, this value here, the question mark, would be equal to pi minus theta. So sine of pi minus theta is the same as sine of theta. The second one is the purple lines. And again, that's just to show that this first green line here, that would be sine theta, that height there, that length is the same as this length here. So if I add pi on, and this gap would be pi, because that gap would have been 180 degrees, then I get the negative answer. I get the negative sine theta instead of the positive sine theta. So that's what the second one says. And that's also true for the third line, which is just saying that these two values here would give you the same negative value of sine theta, and this gap here would also be theta. So sine of 2 pi minus theta would be the same as the minus sine theta. That one we tend not to use very much. It's mostly the top one from when we work out equations, but it's useful to know. I'm not going to go through the other ones with cos and tan, but just to be aware that they're the same, or they're not quite the same. The minuses and stuff are different, but there are values that we can say are similar. So this bottom one this time is the one that we're going to want to use when we're working out, when we're solving equations to find all values of theta. But it is also true that cos of pi minus theta is equal to minus cos theta, and cos of pi plus theta is also equal to minus cos theta. For tan, the middle one this time is the one we would use for solving equations to get all values, because tan graphs have a period of 180 degrees or pi radians now. So if we add pi on, we will get the same value. So that would give us the same value, because the difference between those values would be pi radians, because that's 180 degrees. But it is also true, if we read the top one, that tan of pi minus theta is equal to minus tan theta, and tan of 2 pi minus theta is also equal to minus tan theta. So we can use those things to help us find other exact values. We wrote down in our previous lesson some exact values. I might just go back and take a picture of those so that we can use them. We don't have to write them all down again. That's quite big. Okay, so tan of 4 pi over 3. Well, if I take away a pi from there, cos of 4 pi over 3, that would get me to cos of pi over 3. and we know that cos of pi over 3 is equal to a half. So what will cos of 4 pi over 3 be? Well, if we look at the one that says pi minus theta, that's this one here. Cos of pi minus theta is equal to minus cos theta. So if my theta is equal to pi over 3, then cos of Okay, so I've got a couple of example questions before you work through exercise 5b, and the first one I've got here is that we're being asked to find the exact value of cos of 4 pi over 3. Now I know you can pick your calculator up to work this out, but it is all just helping you get used to working with pi, having a feel of working with radians. So I really urge you not to jump to pressing buttons on your calculator. I really want you to try and think about what we're doing here, what this is asking us for. I've got our exact values from the previous lesson and the cos graph, just because wherever possible I think it's useful to use the graph rather than try and stick to these rules rigidly, because if you forget the rule then you've got no chance. But if we can use the graph, because you're not going to forget what the graph looks like, then we're more likely to be able to get the answers right in a pressure situation. So cos of 4 pi over 3, that makes me think about it's going to be something to do with pi over 3. So let's write down what cos of pi over 3 is equal to. That's equal to a half. So if we draw that onto our cos graph, that gives us pi over 3 being here. Now we're being asked for 4 pi over 3. 4 pi over 3 is going to be this gap here, but after the pi, it's going to be pi plus a third. Let's just write that down as well, that 4 pi over 3 is the same as pi plus another pi over 3. So that's going to give us that blue line. In fact, let's just use that actual blue line because that's then going to be more accurate. Here. So we're after that value. And to me that looks like minus a half, sorry. But shall we check? Why is that definitely going to be minus a half? Well, it's going to be minus a half because we have a rule. We have this rule from the previous page that says cos of pi plus a angle is equal to minus cos of that angle. So cos of pi plus pi over 3 which is our 4 pi over 3, is equal to minus cos of that angle, and our angle was pi over 3. So cos of 4 pi over 3 is equal to the same thing as minus cos of pi over 3, and cos of pi over 3 is a half, so cos of 4 pi over 3 is equal to minus a half. So we've used the graph to help us work that out. We could look at these gaps here and realise that they're the same, but that also links back to our kind of little mini equations that we wrote down that helped us work those things out as well. Okay, so my other example this time is a sine value. I've got a sine graph here. I've brought in our exact values again, and I've written these down, well, I've copied these down again, although I'm going to try and avoid using these. I'm going to stick to using the graph if possible. It says find the exact value of sine of minus 7 pi over 6. So where is that on our graph? That's roughly minus 7 pi over 6. Let's say it's here. So it's this value that we're looking for. Well, we can straight away see that that's equivalent to some other value over here. The next thing I'm going to do is I'm going to remind myself that sine of theta is the same as sine of 2 pi plus theta. Remember that sine graphs repeat every 2 pi radians because it's every 360 degrees. So if I go through one cycle, that will get me to this value here, and that's 2 pi after this value. So what will this value be? What pi value will this be? Minus 7 pi over 6 plus 2 full pi's is going to be 5 pi over 6. Okay, well that's not on this, that's not one of our values, but this is one of our values. So what's that value? Well, we know from our graphs, from the symmetry, that if this value's 5 pi over 6, that means this gap here was pi over 6, which means that gap there is also pi over 6, making this value pi over 6. So the sine of minus 7 pi over 6 is going to be equal to minus 7 pi over 6 plus 2 pi, which is our 5 pi over 6, but that's also equal to just sine of pi over 6. There's no minuses because and again you can look at the graph to check if you want plus or minus, but we're all above the y-axis, the x-axis, so there's no minus sign like there was with that cos example. They're just equal to each other. So sine of minus 7 pi over 6 is going to equal a half, because that's what pi over 6, sine of pi over 6 is equal to. I know this all feels a little bit fiddly, and I know you know that you've got your calculators and you can just pick it up, but please have a go at exercise 5b. It will help you in the long term. It will help you next year when we've got loads of trig flying around and you're not sure how to get from one value to the next. As I said I think I said it with the exponentials and logarithms, if you get stuck next year on something, this is a good exercise to come back to. It's kind of reminding you of the basics. So have a go at exercise 5b, and I will see you soon for the next section.